Check it out now, y'all.
nanoHUB-U, online instruction.
Welcome to nanoHUB University. This is a logistics overview of a course, a two-part course that's entitled Fundamentals of Atomic Force Microscopy. My name is Ron Reifenberger. I'm a professor in physics.
And I'm Arvind Raman. I'm a professor in mechanical engineering here at Purdue.
Together we've put this course, we've organized this course to try and explain some of the fundamentals of atomic force microscopy. There is a separate scientific overview of this course, which is available on the web page, and we encourage you to look at that. The scientific overview will tell you the topics that we will cover in this course. This current short video is more of a logistics overview. It's designed to describe the syllabus, the schedule, and how the course will actually work. So just to remind you, this is a two-part course called the Fundamentals of Atomic Force Microscopy. It will present an in-depth discussion about some of the basic principles underlying the use and practice of atomic force microscopy. Most of the material that will be covered will be developed in lecture. So even though the course material requires a broad background of information, we're going to do a lot of the heavy lifting and provide you with the background material that's required for you to understand some of these fundamental principles. Just as an overview, the course content in part 1 is indicated in this slide. You can see that the course is divided into 5 weeks, and basically in each week there will be 6 topics covered, and the material covered in each topic is indicated in this table right here.
And in this table out here, we've got a brief review of what are the key topics we're going to be covering in part 2 of the class. As you can see, it's a range of pretty comprehensive range of material, starting from point mass model descriptions for dynamic atomic force microscopy, through simulations on Veda, all the way through understanding electrostatic force microscopy, magnetic force microscopy, and applications in liquids to biology. A common feature to both the parts is going to be the use of cyber infrastructure-enabled simulations through the tool called Veda. It's the Virtual Environment for Dynamic Atomic Force Microscopy, and it's going to tie together both these parts in a seamless fashion. It's also going to tie together what we teach in class to your homework problems, because you're going to be using Veda simulations in homeworks to do numerical experiments with atomic force microscopy. Now, Veda is available freely, but you will need to register for nanoHUB in order to be able to use this tool. Some of you already probably have access to nanoHUB on nanoHUB.org and are logged in and registered members. Others who are wanting to sign up for this class will receive an email with instructions on how to register for nanoHUB. But in any case, this will be a prerequisite to be registered on the nanoHUB, so you can use all the tools in nanoHUB, but in particular Veda, which is going to be useful for, in fact, essential for this class.
So it's probably worthwhile to just have a brief discussion about how the course will actually work. And each part of the course is a 5-week set of lectures. On each week, let's say on Monday, there will be 6 videotape lectures that will be made available to you if you register for the course. Each videotape lecture will discuss one specific topic, and our goal is to have each lecture take about 20 minutes. So in all, there'll be about 2 hours of lectures that'll be available to you for at the beginning of each week of the course. In addition to these lectures, there'll be an online quiz that will accompany each of the 6 lectures. This online quiz will ask 1 or 2 brief questions just to see if you understood the basic material that was covered. In the middle of the week, there will be a homework assignment that will appear on the web page. This homework assignment will typically have 3 to 5 problems, and it will accompany each week of lectures. You will basically have 3 days to view the lectures, take the quizzes, work through the homework problems, and enter your answers into any questions that are asked. Following this 3-day period of time, there will be then a video solution that will appear on the website. These video solutions will basically involve a discussion of the homework problems, and we'll try to indicate how the problems should be solved. Some of the problems will involve Veda simulations, and of course that implies that you have access to Veda. Following the homework solutions, a day or so later, there'll be an online exam that will be available. And this online exam will allow you a 2-week period of time to view it, answer the questions, and submit your answers. I believe there'll be like a 2-hour time limit for each exam. So from the time you start the exam until the time you close it, I think you have about a 2-hour period of time to work it out. There will also be a retake option for those of you that might want to retake the exam to improve your score. And then lastly, something that we think is very important is this online form that will be available to anyone registered in this course. This online forum will allow you to ask questions to both myself and Arvin. We'll be at the other end of the line trying to answer the questions, so you'll be basically talking directly to us. And this is something we both feel is important. We welcome the interaction, and we hope to learn about what issues and questions you might have regarding the material that we're presenting in the course. It's probably worthwhile just to give you a sort of a preview of the website for each week of the course. So this is a typical website that we've constructed. It basically tells you which week of the course we're in. It lists the topics for each of the 6 lectures. Under those topics, you can see there are a number of links that you'll be able to click. These links are indicated in red. And the links basically allow you to view the video in a number of different ways. So for instance, you can play the video directly on your computer. Some of you may find it more convenient to go to YouTube to look at the videos. So the videos will be posted on YouTube, and by clicking the YouTube link, you'll directly access those videos. And it's possible that some of you may want to actually download the videos, maybe you have slow internet connection or whatever, and it might take you longer real-time viewing may not possible, so there's also a download link. Under each lecture, there's also a link to the quiz. So after you view the lecture, you can click on that link labeled quiz, and 2 or 3 questions will pop up, which will basically test your understanding of the material. If you also notice, there will be a link to the lecture notes for each week of the course. So you'll be able to download the lecture notes in advance of viewing any of the lectures. And in the event that there are mistakes or typos in the lecture notes, there will be an errata page published for each week of the course. And then in this errata page, we will try to update the lecture notes and correct any errors that may have arisen. We'd like to highlight this discussion forum. By clicking on that link, you'll be able to send a question directly to one of us, and then we will respond in a timely fashion. There will also be a download link for the homework problems. So when the lectures are posted, the homework problems will also be posted. You'll be able to download those problems and read them in parallel with the lectures to try to help you understand the material better. About the middle of the week, this box that's shaded in light blue will appear. The the links in the light blue blocks are basically solutions to the homework problems, and they will involve one of us actually going through and solving the problems and discussing the solution of the problems in a video format. Towards the end of the week, the exam will appear. So the link in the dark blue box will appear on a Friday of each week. Once this box appears, there will be an online exam that you can take, and this online exam will be open for 2 weeks. So you will have a 2-week period of time to actually answer the questions on that online exam. In addition to this information, at the bottom of each web page, there will be a clear definition of the deadlines, the exact dates and times that the exam will be available, when the lectures will close, and so on and so forth. The scheduled dates for part 1 of the course are indicated on this particular slide. So these actually give the start dates for each week, and when the quizzes, the homeworks, the video discussions of the homeworks, and the online exams will be posted. So these are the actual days of the week for this material. Part 2.
Part 2, again, it's a very similar table that lists the starting and ending points of all the key processes and the homeworks and lectures and exams that we have talked about.
So I guess the main point to emphasize is the schedule for the whole course has been reasonably well thought out, and it's laid out very clearly in these 2 tables. It's a fair question to ask how the course will be graded. And basically what's going to happen is, once you register for the course, there's a small fee. I think the fee is $30 for part 1 and $50 if you sign up for both part 1 and part 2. If you register for the course, you will then gain access to all this educational material that's been described in this video. And there are basically 2 approaches that you can take regarding the course. Option 1 is for those students who just want to listen to the lectures and try to understand the material. You're not so much interested in receiving a grade or a certificate that you've actually gone through this course material. So your answers to homework problems and tests will be graded, but there'll be no final grade issued. There'll be no certificate issued at the end of the semester. So this is more of just a learning opportunity if you choose option 1. Option 2 are for those of you that are maybe in a more structured program. Possibly you're taking this course in conjunction with some other nanophysics or nanotechnology course at your own university. Maybe you're working in industry and you have to satisfy continuing education requirements. And for those of you that are interested in option 2, there will be a nanoHUB University certificate issued by Purdue University at the completion of this course, which indicates to anyone that you successfully completed it. Now, to receive this certificate, you do have to make an effort to solve the homework problems, and you do have to make an effort to work through the 5 exams associated with the course. And you will receive a certificate automatically if you sign up for option 2 and you receive a 60% higher grade, or 60% or higher grade on each of the homework sets and on each of the 5 exams. You'll be given 2 tries on each exam, so there's plenty of opportunity for you to try to improve your understanding by reviewing the lectures and retaking the exam. Those of you that receive a comprehensive average, that means 80% of the total points available. If you're successful in earning 80% or higher of those points, your certificate will read with distinction, and it's also possible that some of you will really put in a lot of effort into the course. You'll actually have an average greater than 90%, and in that case, your certificate will read with high distinction. There will be continuing education credits that will be offered for an additional fee, and that information is spelled out very clearly on the web page, the registration web page for this course. So It's up to you to decide which option you would prefer, and you'll have to make that selection at the time of registration. So I think that ends our brief summary of logistics, the overview of how the course is actually going to work. I'm sure there's going to be questions that we haven't anticipated in this short video. There will be a link on the registration page that will allow you to sort out the questions that you might have, and we'll be happy to respond in a timely fashion to any of those issues that might arise. So I think in summary, we hope you find the course material useful and interesting. We worked hard on this to organize this course. It's been taught at least twice already at Purdue University, so we've got some background information on the type of material that should be covered. We're making an effort to organize the material in a systematic way. We're trying to introduce a uniform set of notation, and we're hoping that if you register for these courses, you'll actually receive a much better understanding of how an atomic force microscope works.